All right, so
Is it one word?
What are words?
so
Can we not? My head's gonna
we
explode.
learned the derivatives for sine, cosine, tangent, and then secant.
I did learn this.
We didn't learn those. Well, I taught them. It was up to you whether you actually learned them. I only quizzed you on sine, cosine, and tangent, but just so you know, make sure you have the other ones memorized for the test. Okay. I know there's a lot of formulas to memorize here.
Wait, which ones do we need to know for the test?
All of them.
Even like
Well,
the derivative of secant.
so if I give you secant and you forget it, you could derive it really quickly with the quotient rule. That's fine. So if you forget the secant or the cotangent or the cosecant, if you know the other ones, then it's really easy to
How
derive
hard
them.
do you think this test would be on a scale of 1 to 10?
I'm gonna say like a
I would say a solid 25.
The 4.
Is this one of your favorite tests?
So the derivatives for the inverse trig functions, also known as like your arc sine, arc cosine, arc tangent. Just remember when we have just a couple things with the inverse functions, just recall that we have to restrict the domain so that the function is 1-to-1, passes the horizontal line test, right? Because otherwise, if it doesn't, then it wouldn't be a function, right? The inverse would not be a function. This is just for any graph. So here we have, this is important. If you have the derivative of the inverse evaluated at f of a, it's the same thing as the reciprocal of the derivative of the original function evaluated at a. They're reciprocals. These two slopes here. So the slopes are reciprocals of each other.
The slope of the derivative.
Yeah, this here. So this is the inverse derivative evaluated at f of a is equal to 1 over f, the derivative of f evaluated at a. It's a little confusing. This
Is that an essential part to understanding this lesson? Because I don't get that. I don't know. I get. I
It
get
is.
what
It's
I
going to
get
be
what it's
easier
saying.
when we do an actual example. F of a. So if you think of your original function as f, right? F of a, this is a y value. Remember what the inverse is? X and y's are switched around, right? That's how we find the inverse. Or if you had a particular point, x comma y, to find the inverse of that, you would make it y comma x. So the derivative of the inverse evaluated, and this is a y value, this is f of a, is the same as 1 over the derivative of the original evaluated at that x value. Okay, so this is like right here.
So the one on the left is the inverse.
This is like an x value, and this is a y value. I can't quite fit that in there.
Again.
Okay. All right, so let's look at an example. So here we have a function, x to the fifth plus 2x minus 1. We have a point 1, comma 2 that's on the original graph. So we want to find the derivative of the inverse of 2 without actually finding a formula for the inverse. So basically, this is a way to find the derivative of an inverse without finding the inverse. Sometimes it's easy to find the inverse. Sometimes it's really easy to switch the x and the y, find the inverse, and then plug it in. But in the case like this, how would you do that? We don't have a method to solve. If you were to switch x and y around and then try to solve for y, You'd have a y to the fifth plus a 2y. How would you isolate that? Exactly. So that's why we have this method of evaluating the inverse without having to worry about coming up with a formula. Okay, so this is what basically what I just had above. You see very little of this on the AP, but I've only ever seen like one problem on any AP test, but just in case, obviously we cover it because this also applies to the inverse trig functions. So note that since f of 1 equals 2, we know f inverse of 2 is equal to 1, right? Just switching around. Make sense so far? So let's go ahead. We're going to find the derivative of the original function. So what would that be? F prime. So 5x to the fourth plus 2. So now we want to evaluate.
Are we not supposed to find the formula for? It said without finding a formula
For the
F
inverse.
Not F
Oh,
divided
F
F difference.
So this is just going to be what, 7?
Yeah.
So now we want to evaluate the derivative of the inverse of 2, which is going to be 1 over f prime of 1.
So it's just 1
So it's just the reciprocal, so it's just 1/7. And that's the answer. What's that?
So we never use 2 in it?
We never use 2. 2 is only important to know that from the original, 2 is the y value, but we use the x value. I don't know. Maybe I should have thrown in an extra example. Do you need another example, or is it out okay? It's okay?
It's okay until we get to trig.
Well, so the derivatives of the inverse trig functions,
Whoa,
Alright.
It's
yeah,
really
they're a little
rough.
complicated. They're a little complicated. Just a little. The good news is,
Japanese, am I right?
I'm only going to give you,
She said you can't just drop a bomb on it like this. So it's like we did it. So it's kind of payback for World War II.
the good news is you really only need to memorize these two.
Oh, good.
Oh, God bless.
I went to the National World War II Museum.
I was ready to say something.
Okay.
It's like in there.
On the homework assignment tonight, there are some of the other ones, but you can just refer to your notes. They're not pretty formulas. It's just you have to. So the derivative of sine inverse is 1 over, and then we put square root of 1 minus u squared.
So u squared could be a
dx.
whole function.
U is your function.
So it could be sine 4x plus 3.
Basically, this
And you have to square that.
du dx is if chain rule is necessary.
What?
Okay, so guys, at the end, we've learned chain rule now, right? Which
Yes,
means
you
we
could say.
think of u is the inside, okay? So when we do a derivative, we keep the inside the same, and then times du dx. That's just applying, that's the derivative of the inside.
Which is LP.
So you'll see, the rest of this chapter is going to write out the derivatives this way. So it's going to have something with u, they just use u for whatever reason, but then you'll see du dx, du dx, du dx, du dx. Okay, so same thing here. This is just if chain rules needed. Matthew?
So we're gonna need to memorize all this for the test also.
These two.
This just looks so scary, but I feel like it's not.
It's not, once you get a little practice with these, they're not that bad.
Wait, all of them do you use?
Just-
Is the chain rule needed?
Yeah,
Just
all of
those
these
two?
are chain rule if needed. So the rest of this chapter, like, just to kind of,
But can I take a guess
Go-
here that chain rule will be needed on all?
you'll see here, a to the u, ln of a, du dx. So even future formulas that we learn will all have that du dx at the end. It just means, the only reason we need it is chain rule. So if chain rule is needed, then you'll see du dx.
But it will be.
It will be, because of course you don't get something just straightforward. Why would I give you just sine inverse of x? Because then you would just.
Because we would appreciate that.
So we think of here, think of that as u. That's our inside. So when I want to find dy dx, so here's our formula. It's 1 over the square root of 1 minus 8x squared, but I want to square that, right? Times 16x, right? Because
Oh, that's not terrible.
no, so this is, you just want to multiply by whatever the derivative is. That's the chain rule. That's like what we've learned. Bless you. So we end up with 16x over 1 minus 64x to the fourth. There's nothing you could do to simplify that. There are times where you can simplify, but this is not really one of them.
So this doesn't really use the product rule or quotient rule, nothing like that.
No product rule, quotient rule, just straightforward chain rule. This one. So even though I'm not going to test you on the cosine, just know that it's the opposite of the sign. It's just a negative sign is out in front. Right? It looks exactly the same. There's just a negative here. So what do we have? It's going to be negative 1 over square root of 1 minus 3x minus 4 squared times, what's the derivative of the inside? 3. Now we can just multiply that out, so we get a negative 3 over, oops, what happened there?
Just trying to do that.
Did it just glitch?
Yeah.
I was.
Sure, because it's a surface property. Oh, you have like this.
I can't believe you got one, Gia. You just like.
So-
Okay.
I thought we were supposed to.
Did the screencast stop?
No, it's still done. Me and Emma were supposed to go Surface Pro 3 shopping this weekend, but she bailed on it.
Emma and I.
Emma and I.
Did anybody simplify inside the square root?
Yes, I
We
did.
were always.
Matthew, go ahead.
Negative 9x squared plus 24x minus 15, but that could be wrong.
That's what I got.
Minus 15x
No, just minus 15.
minus
Oh,
15.
wait, plus
Yeah.
24x minus 15.
All right, I'll just put it out of order. So basically,
The order.
so that's it,
You
just
of
different
all
order.
people put it out of
The
order, Miss
order
Casey.
is everything.
Wait, I just ruined my
Just ruined my day.
You were so
Okay,
adamant
okay.
about being a
Oh my God,
woman
you
of
guys are
order.
so good.
How does it feel
No,
to
no,
be
no,
ruined
Make
our
it
day?
awkward. Awkward.
It wasn't that didn't make it awkward.
There.
Okay. I'm satisfied.
My goodness. My goodness.
My goodness.
Okay, here. Okay, a particle moves along the x-axis so that its position.
Why is it always a particle?
Can the particle just stay still?
Guys,
Like, it made my legs so
don't, don't drive me crazy. All right, position. Velocity. So v of t is going to be obviously the derivative of the position. So often we'll see position with an s of t. This one's x of t. So this time, in this case here, u is t to the 1/2, right? So think of u as, remember, it's u is some function within that composition of functions. So tangent inverse. The rule for tangent is 1 over 1 plus, okay, so it's going to be 1 over 1 plus, it's going to be square root of t squared.
So plus or minus t.
Square root.
No,
Square. No.
Square root of t squared would give you the same thing.
that would just give you t.
Yeah.
Oh.
Okay.
Just give you the same thing.
Times, now we're going to multiply by the derivative of t to the 1/2. So that's going to be 1/2 t to the negative 1/2. We're okay with that so far? So what does that look like? Well, we have a 1 over is going to be square root of t times 1 plus t in parentheses. If you want, you can multiply it out. But remember, we're going to evaluate this when t is
Wait, what
16.
happened to the 2?
Yeah, 1/2. 1 to be 1 over 2.
Thank you. I forgot my 2.
Oh, phew, Miss Casey, you can't do that. I have a weak heart.
Oh, is it on the bottom because it was negative? So the
Yes.
negative square.
Yes, so the 1/2 will put the 2 in the denominator. The t to the negative 1/2 will put a square root in the bottom. And obviously this stuff was already in the denominator. So the question here, since t is positive, we don't need to, we don't have to worry about any absolute value or anything like that. Just square root of t squared is t. But t is positive. So because it's positive, we know that the answer itself, velocity could be negative, but when we simplify this is going to be positive. So we have 1 over 2 root 16, and then 1 plus 16. What do we get for that?
8 times 17.
Which is 136.
You were way off. Emma thought it was 560.
That is not what I said.
She said 500.
Because you're so making fun of each other. It's
Oh, she said 546.
Oh, Miss Casey, your numbering is all off.
Oh
What
my-
have you done?
Example 2, you have 2 of those, and then you go to example 4.
Just not my day here.
It's gonna be okay.
You're right. How did I manage that one?
Example 1.
It's not your
Oh wait, we have an example 1.
So this should have been 3.
Yeah.
Unbelievable.
Not yet, Adam, not yet. Yes, Adam, yes.
Okay. Yeah, this isn't a very long section, so.
Noticed.
But we're still gonna.
I would like to look at some of the homework problems, so that tomorrow we don't have to spend a lot of time on homework.
But then what, okay, I'll figure it out.
Okay, so the first set, this is actually something you should have learned in Algebra 2, but students often forget. Cofunctions.
What are
We've heard the
cofunctions?
term cofunctions.
No.
What?
Should we have?
Okay, hold on. Just look at the word. Sine, sine,
Cofunctions.
cosine,
Oh.
Tangent.
Cotangent.
cotangent, secant, cosecant.
Sine, cosine, cotangent.
No! Don't even do it.
I'm not trying to do the song
So they
first,
just
but I'll
have
do
the
the
same
song
sense
if
in
you're the
it?
other one.
I don't get it.
Okay.
Cosine, cosine,
So-
cosine.
Why are these cofunctions?
Because of the name.
Well, part of it has to do with the name. Sine and cosine
Our cofunctions.
are cofunctions because
why?
Yeah.
think
because
about on the
it's
unit
instead of
circle,
one,
guys.
everyone uses
Think about on the unit circle for a moment. When we have, let's say, a 60-degree angle, right?
Sine inverse of what?
Oh, because they're next to
Yeah,
each
these are
other.
supposed to be x's. I just.
Oh.
So this is 1/2. Let's say this is pi over 3, the angle measure. Right? But what would be, so if you think about pi over 2 is 90 degrees. What would be the other angle? Pi over 2 minus that would be pi over 6, which would be the 30-degree angle.
Oh, yeah. Hey, I don't know. I'm lost.
Okay, just take an angle for example.
Yeah.
Say cosine inverse of root 3 over 2 is going to be the same as pi over 2 minus sine inverse of root 3 over 2. I'm running out of room.
Good call. I think so.
Well, what's cosine inverse of root 3 over 2?
Pi over 3.
How about 6?
Now.
And what's sine inverse of root
Pi
3 over 2?
3. That equals pi over 6. Oh my gosh.
Didn't expect it to work.
This case that we didn't expect it.
Okay, another way to look at this, sine, without even knowing that, you may have learned something like this. If these two angles add up to 90, right, the cofunctions have equivalent values. So I could pick any two angles. Like, for example, if I said sine of 10 degrees is going to be the same as cosine of 80 degrees.
80.
As long as
You guys
these
said
two add up to 90, we're okay. So that's why pi over 3 and pi over 6 just have the sine and cosine swap. That's how they're defined as cofunctions. So the same thing is going to be true for tangent and cotangent. The same thing is true for secant and cosecant. And that is why they're called cofunctions, because they have CO in front of them. Cosine. It's the cofunction to sine. Okay.
And why is the abbreviation for cosecant weird?
No, it's not.
Yeah.
That's, just how they abbreviate it. But
Yeah.
if you were
Because
to
they
write
can't
out
do-
secant,
Because they can't do COS again because it's already used. That's why.
I still don't like it. It's weird.
okay, I don't know who made it up.
Funny.
Okay.
All right, calculator conversion. So some of you have, I think there was something that sometimes we run into trouble with plugging into our calculator. So if you have to evaluate secant inverse of something, you have to do cosine of 1 over that. Otherwise, you'll get an error on your calculator. So for example, if I wanted to find out what's the secant inverse of 2, you would put in your calculator cosine inverse of 1/2. Not 1 over, that's
Eli, are you running
different.
the
You
program
wouldn't
right now?
find the inverse of
No.
secant. You would
Just
find,
plugging in cosine.
You would do,
you would find the secant of inverse cosine.
well, there's no secant inverse on your calculator,
Right.
right? So if I say you want to evaluate secant inverse, you're going to use cosine inverse
So
of the
inverse
reciprocal.
first, and then do the reciprocal.
Correct, not the other way around. Don't do the reciprocal of the value.
Wait.
Inverse first. then reciprocal.
Oh, yeah, just hit the button first and then do it.
And cotangent is a tricky one because you have to do pi over 2 minus the tangent inverse. You may or may not have seen that before, but you won't see too much of it, but just in case you do, you can't just do tangent inverse of the reciprocal. You have to use the cofunction identity. All right, let's do this last one. So we want to find the equation of the line tangent to the graph of tangent inverse at x equals -1.
Then how do you know if you put it into your calculator right? Because I got weird answers now, Kevin.
For here?
Like for the cotangent ones and all, the cosecant inverse.
You can, what do you mean?
I like when I put it in the calculator. There's no way to check that whatever I got is the right inverse. Is there? Unless you actually find the actual exact trigonomic identity.
If it's a special angle, then you should be able to like look at the unit circle, but if it's
random angle, there's no
then
way.
you won't be able to. Okay, tangent. What's the derivative for tangent inverse? 1 over 1 plus x squared, and this one we don't have to worry about the chain rule because it's just x. If you were to apply the chain rule, it'd just be times 1. So now we want to plug in, evaluate it at x equals -1.
You're dividing by, you're not dividing by.
So we get 1/2, right? What is this 1/2? This is the slope of the tangent.
So do 2.
Yeah, so what's the, now in order to find the tangent line, we have x, what would y be? Now keep in mind, remember with the inverse function, if it's tangent inverse, you still have to have a solution between -pi over 2 and pi over 2. So you have to have those restrictions that we reviewed at the beginning of the year. Remember how I was reviewing that? Like sine and tangent inverse are from -pi over 2 to pi over 2. Cosine is from 0 to pi. Quadrants
pi
1.
over 4.
-pi over 4.
This is true.
Not 7 pi over 4. It has to be -pi over 4.
My calculator just gave me the negative one.
Your calculator will automatically give you the -1.
So the correct one. It will give you
Your
the
calculator
range.
automatically makes the function 1 to 1, so it'll give you the correct
Ooh.
answer.
Lucky.
So what's our tangent line?
Y plus pi over 4 equals 1/2 times x plus 4.
Okay.
and there's all that space for that.
Yeah, Jordan.
Well, I didn't make an extra
Can you go
example.
back real